Okay, so in this video we're going to discuss same and bottom heavy rationals. Same means that the polynomial in the numerator and the polynomial in the denominator are of the same degree. Bottom heavy, like the example you see in front of you, is showing that you have a polynomial that is a greater degree than what of the numerator. So here we go, let's do this problem. So x-intercepts is step one. We always want to try to figure out what our possible x-intercepts are. So our possible x-intercepts are the what makes 0 for the numerator, because that's the only way you can make 0 out of a fraction. So the value there is -5. 0 would be a possible. Now I always say possible because it's possible to come back and get rid of it. Now the next thing we have is vertical asymptotes. So vertical asymptotes are found by what makes the denominator undefined. And what makes the denominator undefined is found by doing its zeros. So to find the zeros of a quadratic, in the videos that I'm doing, we will be able to do them by factoring. If not, you could do them via quadratic formula. So I'm going to go ahead and factor this. So x squared plus 9x plus 20 factors into x plus 4 times x plus 5. Okay, so my vertical asymptotes, are going to be the values of the zeros of those two linear pairs, which is at -5. Oops, sorry, I should write this. So it's at x equals -5 and -4. So I'm going to go ahead in red and I'm going to plot them down through. So at -5, so we draw vertical asymptotes with a dashed line. So there we go. And then my second one's at -4 here. Okay, so there's your vertical asymptotes, and then the next thing we move on to is horizontal asymptotes. Now, bottom heavy or simple. All bottom heavy, all of them, every single one of them will have a horizontal asymptote along the x-axis. Okay, so if you're looking for an explanation for it, I can give you one later, but for right now, you just need to know it's at the x-axis, which has the equation y equals 0. So more commonly, you will see the horizontal asymptote written as y equals 0, as opposed to just saying x-axis. So it's a memorization. So in the next example that I do, that will be another bottom heavy, you will see that I will probably start the video off with just the horizontal asymptote saying it's y equals 0. You can fill it in. You don't have to do it in a particular order. Now, from a matter of here, it's just a matter of determining holes. Now, holes are determined by determining, do you have any numerator and denominator factors that reduce, so linear factors. So in this case, x plus 5 and x plus 5 both reduce with one another. So the whole will start off at the 0 of that linear factor. So it's at -5. Now, to figure out its output, what you do is you plug it into the reduced form. So f of x equals 1 over this x plus 4. So what I do to figure out its output is I will now evaluate f of -5, and I plug that in. And when you plug -5 in, you get 1 divided by -1, which is -1. So I have a hole at -5, -1. So what I'm going to do is I'm going to go ahead and plot that. So I'll go ahead and I'll plot that hole at -5, -1. So -5, -1, there it is. Okay, so then from here, it's just a matter of graphing this function. The way you graph the function, as I've described before, is pick some points that are far from your asymptotes, pick some that are close to your asymptote, and then pick some others that are a little bit farther away. So for this particular function, because I know that the reduced form is actually a reciprocal function, what you can actually do here is if you know what a reciprocal function looks like, you can go ahead and literally you can graph that. You can know that this reciprocal function shifted from the center 4 units to the right, and then it's just going to be the graph of the original reciprocal function. So in this particular case, okay, what I didn't do here that I noticed is I didn't graph in my horizontal asymptote. So let me just go ahead and draw that in over this x-axis. So I'm going to go ahead and do that. Now, I personally, me at my level, okay, of knowing this, I would graph it just based off the reciprocal. I would look at this and say, okay, this is just going to be a reciprocal function. But if you don't have that memorized, then the easiest thing to do is just pick points and plug them in and plot them. So the first point I'll plug in then is -10. So I'm going to evaluate my reduced function for 1 over x plus 4 for, say, -10. You plug a -10 in, you get 1 divided by -6, which is -1/6, so there's my point. Okay, and then I'll plug in negative. Now I have to choose something in between my asymptotes here, so I'm going to plug in 4.5. Okay, so if I plug in 4.5, Okay, what I get is when I plug that in, I get negative 1/2. 1 divided by negative 1/2 is negative 2. So I'm going to go down here and I'm going to plot this point. So what I have here, as you can see now, is I have the curvature of this thing starting to form. It's heading towards the horizontal asymptote. Okay, and then it curves down towards the vertical asymptote. Okay, so then just going to the other side here, I'm just going to go ahead and I'll plug in negative 3. So now I'm plugging in a point to the right of this vertical asymptote, negative 3, plug it in. 1 divided by 1 is 1. So f of negative 3 has an output of 1. If I plug in, say, just to see the curvature here of negative 3.5, plug in negative 3.5, you get 1 divided by 1/2, which is going to be 2. So at negative 3.5, it's 2. So I can see that this curvature is going up. Okay, and then I'll plug a point all the way to the right, so say like 10. So I plug 10 in and I get 1 divided by 14. So that makes me a number really close to 0. So what I'm starting to see here is that this thing curves down and it just heads down towards this horizontal asymptote. And then that's it. So that's how you graph those bottom heavy ones. So then from here, I have to do range and domain. So domain is all the values for which x cannot be. So x cannot equal negative 5, nor can it equal negative 4, but it will equal everything else. The range is all the values that it could be as well, but sometimes it's easier to describe range as to what it can't be. The range can go from negative infinity up to 0, and then from 0 to positive infinity. So the best way you could just write this is just y cannot equal 0, and you'll have your range described. All right, let's go on to the next example. Okay, so for this problem, we're going to talk about a special one here, and we're going to talk about this idea of an asymptote a little bit more, especially for horizontal asymptotes, and you'll see that in a little bit. So for vertical asymptotes and horizontal asymptotes, they're a little bit different. Well, I'll explain that when we get there. But for right now, let's just go ahead and do this problem. Let's follow our steps as normal. So the x-intercept, okay? So the x-intercept is the zeros of the numerator, and this one you can kind of easily see that if I plug in negative 2 in, I will get a 0. And then the next thing I'm going to do is the vertical asymptotes, and that's the zeros of the denominator. So that's found by you factoring it first. So this factors into x plus 1 times x plus 4. And then each linear pair, and you find that your vertical asymptotes occur at the values of x equals negative 1 and negative 4. So I'm going to plot this in a second. Now the next thing here is I have a horizontal asymptote. And a horizontal asymptote is always going to be for bottom heavy at y equals 0, otherwise known as the x-axis. Now, an asymptote is, I just want you to understand something, okay? So an asymptote, there's a horizontal asymptote and a vertical asymptote are a little bit different. Vertical asymptotes make something undefined, okay? So therefore, you can never, ever, ever cross a vertical asymptote. Like you can't actually have a point on a vertical asymptote. However, if you look at my x-intercept and you look at my horizontal asymptote, okay, the horizontal asymptote is slightly different, all right, because a horizontal asymptote is just going to be a line for which your graph tends to head towards that path. All right, so it tends to mimic it. So what you can understand here is that inevitably, look, you can land on, touch, or even cross a horizontal asymptote. You cannot cross verticals, but you can cross horizontals, and this is a great explanation of how this could happen. So, do I have any holes? And the answer is a hole is found, moving forward here, a hole is found by seeing, do any linear factors in the numerator and denominator, do they exist? And the answer is they do not exist. So there are no holes, there are no points that are going to be an undefined value, okay? So here we go. So let's go ahead and do this. So the first thing I'm going to do is I'm going to plot in my horizontal asymptote of y equals 0. And remember what this means is that when I'm done graphing this, what you will see is that as my graph heads towards negative infinity, my line is going to curve towards the horizontal asymptote. And as I head towards positive infinity, my graph will head back towards that as well. but it does not mean that you can't cross a horizontal. However, you cannot, and I explicitly want you to know this, you cannot cross vertical asymptotes because they are defined as what makes a function undefined. All right, so here we go. Drawing in the vertical asymptotes at -1. So -1, there it is. And then again at -4. So from here, what we have to do, and there's no easy way of doing this, we just pick points, okay? So you're going to pick some points far to the left, in the middle, and far to the right. So here we go, picking my first point here. All right, I'm just going to evaluate f of -10. And when you evaluate f of -10, what you're going to get is you'll get -8 divided by, in the bottom here, you will have -9, okay, times -6, which is 54. Now, 8 divided by 54 is a number just close to 0. For graphing, I'm not worried about getting exact. I just want to know that it's going to be close to it, all right? So then the next number I'll choose is -5. So I'm going to evaluate this function in the -5. So it's like I'm taking f of -5, and you can plug it into the factored form or the unfactored form. I always find it easier, me personally, to plug them into the factored form. So if I plug it into the factored form, my numerator becomes -3, and my denominator becomes, well, -5 and 1 makes a -4, and -5 and 4 makes a -1. So that's -3/4 in this particular case. So there we go. So I have a negative, all right? And then I'll check another one. So I'll check a number really close. So say like -4.1, all right? Just a little bit to the left. And when you plug that in, you may need a calculator to check the ones really close to your asymptote. You can go ahead and you can plug that in, and what you get is a value. And that value is -6.77. So really close, okay? So it's -6.77. It's right here. So as you can see, my line is curving towards the horizontal asymptote, goes here, and goes back. Now, it's not to say that this thing won't cross this and then curve back towards it, but in this particular instance, we just draw a line that's heading towards the horizontal asymptote, so there's my left-hand side. Now let's go to the middle. Middle, we already have one value. That's going to be an x-intercept, and there it is. Don't worry about it. Plot the point. Do not make it an open circle, okay? So as described, you are allowed to do this. All right, so then, next thing we have to do is get another number. So I'm going to take, and I'm going to plug in -3 just to see where I end up. So if I plug in -3 here, so you plug in -3, so now I'm just evaluating my function for -3. So if I evaluate for -3, so f of x, plug in -3, you get -1 in the numerator, and then you get the value of -2 times, okay, and in this case, you multiply it and you get the 1 here. So -3 and 4 make 1. So -1 divided by -2 is 1/2. So at -3, I've got this. Okay, so just moving forward with this, I'm just going to check my next point. And my next point I'm going to check is -1/2, some number in between this vertical asymptote and -2. And when I plug into the calculator, I get this -0.4. So -1.5, -0.4, which is kind of important because what this shows me, oops, what's going on here? Okay, so what this shows me is that this curls up, okay, and that this one is going to curl down like such. So there is my graph, okay, in the middle. So there we have. So I clearly can cross over horizontal asymptotes. Okay, and the next thing I'm going to do is I'm going to go on to the next problem. Onto the next side here, next side here, and what I get is plugging in some numbers. So plugging in 0, if you plug in 0 and you can evaluate, you get 2 divided by 4, and 2 divided by 4 is 1/2, so you get an or a y-intercept of 0, 1/2. And the next thing I'll do is I'll plug in, say, like the number 10. So evaluating for f of 10, you would get 12 divided by 11 times 14, which is just going to be a larger number. So that thing is going to be close to 0, just using some number logic. And the next thing I'm going to check is, say, -1/2. And if you check in -1/2 here, all right, what you end up getting is a value that heads towards positive here. So if you plug in that negative 1/2, okay, I can give you the exact value in a second here, but if I plug in negative 1/2, then I get 1.5 divided by 0.5 times 3.5, and I just want to show here that it's going to be a positive value, and so because it's going to be a positive value, it's going to head towards it's going to head up. Okay, on to the next problem. All right, so let's now take a look at some example of things that are the same. So there are some rules for the same, and we're going to go through those. So first off, we do these problems the same as every other problem. We first find the x-intercept, what makes the numerator 0. So the x-intercept in this case is what number can I plug in for x so that the top becomes 0. And clearly if you plug in a 3, the numerator will become 0. So I got an x-intercept at the point 3, 0. Vertical asymptotes. Asymptotes are what make the function undefined, and fractions are undefined when their denominators are 0. So at this case, if x is equal to -1, I have a vertical asymptote. Horizontal asymptotes, what you must do is factor top and bottom. So this factors into 2 times x minus 3 over x plus 1. Not horizontal asymptotes, sorry, that's for holes. So for horizontal asymptotes, my bad, horizontal asymptotes, what you're going to do, okay, is you will take the leading coefficients. So the degree of a polynomial is described as the variable with the highest exponent. So in this case, okay, the degree for this is linear, that's how you coin the name. So if I take the coefficients and divide them, okay, it is 2 divided by 1, so I have a horizontal asymptote at y equals 2. All right, so that means as my graph goes to negative infinity, the graph is just going to head towards positive 2, and as I head towards positive infinity, my graph is going to bend back or curve towards positive 2. All right, and you'll see that on this graph when it gets drawn. So for horizontal asymptote, if they are the same, the key to it is just taking the fraction of the degrees coefficient. So at this point, we need to analyze holes and analyze. All right, so for holes, if you have any linear pairs that reduce the numerator and the denominator, if they cross out, in this case, we don't have any because my linear term at the top is x minus 3, and at the bottom, it's x plus 1. So for this example, my holes do not exist. So we're just going to go ahead and now we're just going to get to graphing. So in this problem, f of x is equal to 2 times x minus 3 all over x plus 1. Sorry, that's my kids who are being annoying in the background, so I apologize. So what we'll do is we'll go ahead and we're going to graph this one. So the x-intercept, first thing I'm going to plot is 3, 0. Get this in blue, so 3, 0, there it is. The next thing I'll do is I'll plot the vertical asymptote, which is at -1, so I always plot those in red. So there we go, -1. All right, and then from here, what I'm going to do is I'm going to draw in my horizontal asymptote. So now remember in the last example I just went over here, it doesn't mean that you can't cross this. It just means that as I go to the right forever on my graph, it's going to bend towards it. And if I go to the left forever, it will bend towards it as well. All right, so let's just go ahead and do these problems. So I'm going to pick a number now that's kind of close to my vertical asymptote and on the left and right of it, and we'll go from there. So I don't got to get too close for this one, so I'm going to evaluate it if I plug in 0. So I'm going to evaluate f of 0. So plugging in f of 0, I get 2 times -3 divided by 1. So that gets me -6 over 1, which is -6. So that means from this point here at 0, it's going to bend downward. So that's important. So now at least I have this part of curvature is heading down here. So now the question is does it cross my my horizontal asymptote or does it not? And the way you figure that out is just by plugging a number far to the right. So let's just say I pick a number and we'll evaluate, say, f of 20. So if I plug 20 in, I get 2 times 17, all right, divided by 21. And the question is will that number be a number that's greater than 1 or less than 1? All right, or greater than 2 or less than 2. So if I pick something out far enough, I can probably get an idea. So this is 34 divided by 21. And what I'm just going to share with you here, just so you understand this, is that this produces a value that inevitably is less than 2. So my curvature is going to stay below, and I'm just going to presume that it's not going to cross the horizontal asymptote. Okay, so let's go to the other side of this thing and let's start plugging some numbers in. So let's try evaluating it for f of negative 10. So doing f of negative 10, I get 2 times negative 13, which is negative 26, divided by plugging in a negative 10. All right, you're going to get the value of x plus 1 is negative 9. So 26 divided by 9. Okay, is 2.88. So at negative 10, I get this 2.88 here. So then going a little bit closer, let's just say we're going to plug in, let's plug in negative 2. So if I plug negative 2, so evaluating this function for f of negative 2, I get 2 times negative 5 all over negative 1. And 2 and negative 5 make negative 10. Negative 10 divided by negative 1 make positive 10. So at this point, I get here. And what I can conclude here is that this thing here is going to come down here. It's going to curve. And then it's going to head towards here forever. Again, when doing these graphs, we're just trying to get the general shape of them. Okay, so that's it. That's how we did that same one. Let's go into one more example here. So one of the things you kind of want to notice here is that I am just graphing these things by going old school, by just evaluating them. So out of Algebra 1, that's kind of why you really had to learn evaluating function notation, because that's what I'm doing here. So if you're getting lost in how I'm drawing the graphs, you might want to revisit evaluating function notation, because all I'm doing is plugging points in, getting outputs, and then literally I'm plotting them on the graph. Okay, so on to our last one. So the first thing I'll take care of here again is the horizontal asymptote, and the horizontal asymptote is found because these two polynomials are of the same degree. The top's a quadratic, the bottom's a quadratic. What I will do is I will take the leading coefficient right here and here, and I will divide them. So when 2 divided by 1 is y equals 2. So I have a horizontal asymptote at the value of 2. And sorry, they won't all always be this way, but just for the examples I chose, I guess I got 2 and 1 here. Okay, on to the next one. So the next thing I'm going to do is the x-intercepts, and the x-intercepts are found by what makes the numerator 0. So I'm going to have to factor this top here. So factoring this top, so I get f of x turns into this 2x and then an x here. Okay, so this is one of these has got to be a negative one, and one's got to be a positive one. So that's going to be negative, and that will be positive. And then I divide that by, and I'm just going to go ahead and factor this right now while I'm at this. So x squared minus x minus 12 factors into x minus 4 times x plus 3. So x-intercepts. X-intercepts are going to occur at what makes the numerator values of x make it 0. And in this case, the first one you get here is negative 1/2. So I have an x-intercept at negative 1/2, 0. And I have another potential x-intercept at good old positive 1. Oh, sorry, 1 comma 0. That might help, right? 1, 0. And then vertical asymptotes are the things in the denominator that make it 0. These things are going to be undefined. So to be undefined, I'm going to have one at x equals negative 3. And I'll also have one at 4. Now, just before I start graphing anymore, let's just talk about holes again. Holes, do I have anything that reduces the numerator denominator? And the answer is no, there are no linear pairs that reduce. So in this case, it could be quadratic pairs as well, but in this case, they do not exist, okay? No holes. So what I need to now do here, okay, is I need to graph everything in. So I'm going to put in my horizontals already there. I'm going to put in my verticals. So my vertical asymptotes are at negative 3. And then they'll be again at 4, so positive 4. Okay, so here we go. So then again, it's literally plug it in and get an output. So here we go, plugging in numbers. So a number that I'm going to try first is negative 5. So if I plug negative 5 in, I get 2 times negative 5, which is negative 10. So plus 1 to that. All right. So if you want to use a calculator, go ahead. Negative 10 plus 1 is negative 9. And then negative 10, negative 1 is negative 11. And I divide this by. So again, negative. Wait. I plugged in negative 5. Sorry. Negative 5, that's not negative 11, my bad. So that's negative 6. And then negative 5 makes this negative 9 here divided by negative 2. Okay? So what I want you to understand here is that at negative 5, I'm just going to get an output. And that output is 54 divided by 18. And 54 divided by 18 is 3. So at negative 5, I get an output of 3. So there we go. So then I'm going to check. Let's evaluate if I plug in negative 4. So again, if you want to, go to the calculator. I think I'm just going to go to the calculator, try to make it a little bit quicker for me as opposed to walking you through it. So all I'm going to do is evaluate f of negative 4 here. So 2 times negative 4 plus 1. I can do negative 4 and negative 5. That's negative 5. All over, so negative 4, that's negative 8. So negative 8 times negative 1. Okay, great. So you get 35 over 8. And 35 over 8, 35 over 8 is 4.37. So when I did this problem, right, what I got was I get 4.37. So here, what it's showing me is that it's starting to curve up, which is important. So there we go. So I have this, and it's starting to curve up. Now, I'm not going to assume that it doesn't cross this horizontal. So what I'm going to do is I'm going to choose a number that's really small. So I'm going to pick a number, say like negative 20, all right? So I'm just picking numbers. If you want to choose negative 100, you can choose negative 100. It doesn't matter. But I'm just going to use negative 20 so that I can do some quick mental math as best as I can here. So that gets me negative 39 times in the top here, negative 21. Okay, and that gets you 819. So the numerator is 819. So I'm not done, but here we go. I get 819 when I plug it in. And then checking the bottom, so negative 20 is going to give me negative 24 times negative 17. And negative 24 times negative 17 is 408. So I get 819 divided by 408. So taking 819, divide that by 408, and what I get is I get a number slightly bigger than 2, which is important because then I'm going to presume that I'm not actually going to cross this horizontal asymptote, and there you go. So there's that left part. So now we go to the middle. So I have some stuff here, which is kind of nice. At negative 1/2, I cross the x-axis, and then look at that again, I cross it at positive 1, so I already got some points. So the next thing all I'm going to do is check for, honestly, is the y-intercept. So I'm going to plug 0 into this thing. And when I plug 0 into this function, I get, in the numerator, if I evaluate this for 0, I get, when plugging in, I get 1 times negative 1 all over negative 4 times 3. And what I get there is I get 1 over negative 12. So 1 over negative 12 is that's negative 1 over negative 12. So negative 1 over negative 12 is a positive number, and there it is. So that's important because basically what I'm going to presume here is that this is going to curve down. So because it was a positive number and I have to cross the x-axis, I'm going to presume that it goes down forever. It can't cross back up, right? So there we go. So then going on to the next one, just plugging in a 5. So I have an option here. It could go like this, or it could go like this. So that's why I'm plugging numbers in to find out what kind of curvature I've got and where it's at. So let's plug a number in. So I'm going to plug 5 in. So 2 times 5. So evaluating this function for f of 5. Okay, so f of 5 equals 2 times 5, which is 10. So that's 11 times 4. All over, so plugging in 5, I get 1 times 8. So that's easy math. I can do that in my head. That's 44 times 8. So 44 divided by 8 is exactly 5.5. So now when I plug in 5, I get 5.5, which is kind of nice to have. So at 5, I get 5.5. So then I'm just going to now check a really far number away. So I'm just going to plug in positive 20. So I get 41. So for the first one, so I'm evaluating this f of 20 here. So, and I'm going to see, does it cross over the horizontal asymptote? So here we go. So I plug in 20 and I get 41 times 19 all over 16 times 23 when I plug in for f of 20. So 41 times 19, oops, sorry, that's the wrong one. 41 times 19 is 779. And then 16 times 23 is equal to 368. So I take 779 divided by 368, and I get a number that's just above 2. So I'm going to presume again that this thing is going to not cross this horizontal asymptote, but yet it is going to oops, sorry, I didn't mean to do that there, but that it is going to kind of head towards it. So here we go. So I'm going to have my line, I'm going to draw it in. And it's going to go down through this point. It's going to curve down towards this horizontal asymptote, but it's not going to pass it. And there you go. I'm now done. I do apologize. I know this video is quite long, but there's a lot of work that goes into graphing these things. So there you go. All right. Hope it helps.